In this video, I'm going to go through a quick exam. Now this exam is going to be MCQs. It's going to be half the size of a regular exam, but hopefully I'm going to cover many of the topics which this course taught us, and you may find that this is useful for your review. So let's get started. Question 1. Here we have a method which is called get the result. It takes an input of an integer. And let's take a look. We've got a for loop here which starts at 1 and number is less than n. So n we recognize from here. Okay, so it's going to go up to, but not including the value up here. And then it's going to increase by 1 each time. All right. It says if number modulus 2 equals 0. You should recognize this to say if the number is, so if number is even. Basically this thing here, if you divide it by 2, there's no remainder. Okay. So if it's even, we're going to multiply product by the number. Okay. From 1 up until the number we've given. So in this example, it wants to do the for loop here and then return at the end. And we're going to give it a value of 8. So what will this give us? Well, we're going to start with number is 1 and go all the way up to 7. As you see, because the loop won't include 8, it'll be less than 8. And we're going to only multiply the even numbers together. So we're going to multiply 2, which is going to multiply by 4. Which is going to be, that's going to be 8, multiplied by 6, which is going to be 6, 8, 48, right? And so therefore, I would imagine that our result would be 48. And if I just check the answer here, 48. That's our answer. Question 2. Okay, process words method. Assume that it's each two parameters is a string of length 2 or more. So these two strings is input, word 1, word 2, and they have length of 2 or more. So here we're taking substring 0, 2 for the first word, and we take substring, and this is length minus 1. Okay, so that's interesting. Now, substring, if you remember from the quick reference, substring with 2 arguments means the from and the to. In this case, when you've just got 1 argument, it's going from a certain position and then all the way to the end of the word. And the result is going to be string 2 plus string 1. And we print out the result dot index of string 2. All right, so what does indexOf do? Well, indexOf returns the index that this string is in the result, right, or the word here. So we take the word, the variable of the word, and then saying, where does string 2 occur in that word? If it doesn't occur at all, it's going to return minus 1. So look at the last 2 lines here. I mean, we can sort of take a look up here. I mean, this is maybe I would say more of a distraction. So the result is made by string 2, whatever it is, adding together with string 1. So therefore, the result of this index of string 2, well, it's always going to appear at the start of the array. At the start of the string, because string 2 plus string 1 is the result, right? So string 2 occurs first, string 1 second. So the index of string 2 in result would always be 0 because it occurs at the start and index 0. So I would say we have A. The value 0 is always printed. Okay, next question. Okay, random numbers. Random numbers are basically, one of the tricky things, but I have covered a video about random numbers. But in this case, we're asking for random numbers between 25 and 60 inclusive. So it includes 60. Okay, so we're trying to get the value where it's getting up to from 25 to 60. Now, let's remember, random generates a number between 0.0 and 0.99999. So we usually multiply by the number that we're going up to. But in this case, it's a little bit different because we have to only do it between 25 and 60. So we have a kind of a range of numbers here, and if we minus 60 by 25, we end up with 35. Okay, so we've kind of got a range of numbers 35 in length here between them. Okay, so to include 25 and 60, there's actually a total of 36 numbers, I would say, between the two of them, right? So actually the range is what we're doing. When we multiply, we're getting the range here. So therefore, I would suggest that instead of just jumping to like multiply by 60 or multiply by 25, we have to consider that this is actually, we need to multiply by the range we need and then add the 36 at the end, right? Sorry, add the 25 at the end because we're shifting it along. So we're multiplying by 36 and shifting by 25, I would say, right, to move us along. Okay, this is a variation on the standard algorithm because we're actually looking for numbers between 25 and 60. Normally we go from 1 to whatever number, but this question makes it a little harder. So I'd say D here is the answer, right? We have a range of 36. We do the range first, and then we shift it along 25, right, to get up to there. Takes a bit of practice, but the more you do practice with random numbers, the simpler it'll be. Okay, at certain high school, students receive letter grades based on the following scale. Okay, so here we have an if and else kind of scenario where we have to put these grades into a system of logic. Okay, usually the way you do these is you do the most restrictive one first. So the most restrictive one is 93 or above. We can put that in as A. So look for 93 or above. So 93 or above that, and then we should look for the next one, right? Now the problem with number 1 here is once it runs the first if, it's not, the next if will get run as well because this if is not connected to this if. There's no else here. So therefore, when it finishes this one, it could find, like if the score was, for example, oh no, actually no, it may not, because it has 2 conditions in here, so it may match it. So let's say if our score is above there, it will do this one. If the score is above or equal to 84, and it's also less than 92. So this is trapping it within these conditions. It's going to do B, and also trapped within above 75 and 83, C, and less than 75. So that actually one would work because it's specified these conditions narrowly, each one. Okay, rules for each condition. 2, let's check out 2. Now, 2 greater than 93 or equal to, this would work. Now, this is saying less than 75 and less than 83. So that wouldn't work because it can't both be less than 75. And it's going to affect by 83 here, less than or equal to 83. This is just less than 92. So actually, if the it may not, let's see, we have 93, and then we can ignore this one because okay, so we'll look first of all, you can't write it this way. So actually, I should have seen that at the start. You can't write the if statement this way. You have to write it with and. You have to do 2 separate statements. So clearly 2, it should have been obvious. Okay, so we can ignore all of that. This one, 93 above, 93A, else if. So it's trapped within the else if section. Score is greater than 84. Well, it would have already failed this, so it would have been less than 93 for it to get to here. And then the next condition is greater than or equal to 84, right? So it would have been this situation here. And then the else if greater than 75 or else F. Okay, so I think these are two ways to do it. 2 is not. So I would say that our answer should be 1 and 3 only, which would be D. Okay, I probably could have got that a little bit faster, but I think that'll show that that's the answer. Okay, 1 and 3 only. Next one. Okay, so here we have a Boolean statement, and I will note that we are doing, when you see a statement like this, usually what it's asking you to do is some equivalency, and for that we need to look at DeMorgan's laws. Okay, so if you remember DeMorgan's laws, there's a 3-step process, and I have another video for that, where you talk about flipping the outside part. Okay, so from not you add another not, and those two knots would cancel each other out. You flip the operator, and then you not each of the sides of the operators, right? The operands. So what you're going to end up with here is we subtract this not, we change this to an and we not in front of each thing here, which would cancel this one and would put one here, right? Not C or not D, right? So it would put a not right before the bracket parentheses there. Okay, so does that correspond to anything we see, or do we still have to go further? Let's see, we get kind of close here, but it wouldn't. We might need to take one more step. Okay, this is close to what we need, but it's not quite. But if you see that we can actually, once we have that one in there, we can then flip, so add another not here, which would give us 2 knots, and then flip this one to an and not the C and not the D, which would cancel that one out. So that would end up with this. So I think our answer here would be A. Okay, so DeMorgan's laws would basically just using the same kind of 3 steps. Not the start, flip the operator, and not each of the operands. Okay, each of the sections. Okay, so that was 2 steps. You shouldn't really need more than 2 steps for these type of questions. 2 or 3 steps maybe. Okay, next one. So the following method, mystery. Okay, we have a mystery method, and let's look through here. We in the middle we have some kind of to do with even numbers, I'd say. So we take a num, and we have a while loop while x is greater than 0, x equals to num, and then we're going to do something to x to see do we return. So basically, if x divided by 10 is an even number, right? So this would happen first, x divided by 10. Check it to see if it's even. If it's even, return x. Okay, return not x divided by 10, return x. If it's not even, divide x by 10 and save it back into x, and that changes the value of x, and then we do the loop again. So what this is doing is it's going to keep dividing the number by 10 until the number divided by 10 is even. And what do we start with? Well, we start with 1034. Okay, so let's see how this would proceed. 1034 comes in here, right? And it gets saved into x. The loop runs. 1034 divided by 10 would give us 103. 103 is not an even number, so therefore x gets divided by 10. Remember, x is still at this point 1034, but now it gets divided by 10. Now 103 gets saved back into x. We loop again. Okay, so now x is 103. So x is still greater than 0. 103 now gets divided by 10, which would give us 10. Is 10 an even number? Yes, so it returns x. Remember, x at this point here is still 103. It hasn't been divided by 10 yet. This is a theoretical division by 10, right? If x is divided by 10, x is the value 103, divided by 10 makes it 10, but it doesn't change the value of x. So x is 103, so it's returning 103 here. So therefore, our answer would be D. Okay, next. So how am I doing for time? I've done about 15 minutes here so far, and I've done 6 questions. So roughly, I'm a little bit behind. I'd like to do 2 minutes per question. I am doing a bit of explaining, but I'll try and catch up a bit. Okay, so for int k equals 0, so here's a standard for loop. We start at 0, and it's a less than symbol, and we have the number here. We're usually doing 20 loops. However, standard loop is not, because we're adding 2 instead of normally k to add 1, but this one's adding 2. So we're increasing by 2 each time. So we're going to go from 0 all the way up to 18, because it's not going to include 20. Now, if k divided by 3 has a remainder of 1. So which numbers, when you divide by 3, have a remainder of 1? Well, let's think about it. It's 4, and then it would be, let's see, divide by 3, so 8, no, sorry, 4, and then it would be 7, right? Because 6 divided by 3 would give even, and then 7 would be remainder of 1. So 4, 7, what about 1? Actually, 1 would work too. But now, would k ever be 1? No. In this situation, remember k is jumping on. It's only on the even numbers here. So basically, which even numbers between 0 and 18 would divide by 3 to give a remainder of 1? So let's see. We can say that 6, 7, well 7 won't occur because that's an odd number. 8, 9, well 10 would be 1 because 10 fits on the for loop, and when you divide it by 3, right, you get, 9 divides by 3, and then it's got a remainder of 1, right? So 10 would fit, and then I think 16 would be the other one, right? So we'd be looking at answer B for that one. Okay, question 8. Okay, we have output of this, right? 5 1s, 4 2s, 3 3s, 2 4s, and 1 5. And we're looking for the code that would print that. Alright, so it's clear that we have 2 loops running. On the first loop, we're printing out 5. And by the last one, we're actually just printing out 1. So it occurs to me that this isn't just a basic loop. We have some kind of limitation in here that's getting bigger each time. So what we're looking for is that we're printing out, well, we're clearly, if you remember your experience with 2D arrays, you remember that usually the outer loop is the rows and the inner loop is the columns. So as we're printing out 1 many times, you can see the value of the outer loop would be 1, right? And this is the outer loop going here, and then outer, 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 and the inner loop is 1, 1, 1, 1, 1, right? So the inner loop is printing the value of j. So the j is the outer loop, the inner loop is just printing that j so many times, right? Printing 5 times, printing 4 times, printing 3 times, 2, 1. And so why would it be printing 5 times? Well, it's kind of going smaller each time. So the inner loop is getting smaller each time. It's running smaller times, right? So does this work here? No, this seems to be printing k equals 1, k less than equals 5. That would just print 5 times each time. So that's out. Okay, this one 1 and k less than equal j, so that it would keep printing. Well, j is 1 here, so that would print only 1 the first time, and then when j gets bigger, the number of times it prints would get bigger. So that's not true either, because it's actually the opposite. The higher j gets, the less k prints. So we're looking for the opposite thing here. Now let's see, k equals 5. Now that makes more sense. K equals 5 and k greater than or equal to 1, k minus minus. Well, that's going backwards, but you can see here k would just be basically just reversing through each single time. It would do the same thing. It's not really related to j here. It would just print 5, and then the next time it would print 5, and it would print 5. So that's out too. Okay, so this one here, we have k equals 5, k greater than or equal to j. This looks better. Okay, so this one, we start with 5, and j is 1, so it goes 5, 4, 3, 2, 1. Then it goes, j is 2, so it goes 5, 4, 3, 2. Then j is 3, it's 5, 4, 3, etc. You can see it's shrinking in the amount of loops that the inner one does. So I would say we found our answer, and that's D. All right, keep going. Okay, here we have an example, and we haven't got a constructor. So we're looking for correct header for a method of the example class that will return the private instance variable x so that it can be used in a class other than example. So what we're looking for here is, doesn't matter about the constructor, we're looking for something that's going to return this. It's private, we can't access it directly. We're going to write a getter method, right? A get method. So we need, first of all, that it should be public, that it should return an int, because that's the type of number that we're returning. And it should, doesn't really matter what it's called. We don't need to have any input for this method, because all we're doing is getting the value and returning it. So that looks like it would be C. The problem with A is it's private. That won't be accessible from the outside, private. And this is void, it's not returning any value, but we are actually returning an int. And this is taking input, which is not necessary. So the answer is C. Okay, question 10. So here we have a code segment which has an array, and then we have an enhanced for loop which goes through that array and adds 10 to each value and prints it out with a space. Then we have another enhanced for loop here at the end which just goes through and prints the values straight. Now what it's trying to do is confuse you with this has curly brackets and this one doesn't. But what you should know is that it doesn't matter that much that there's curly brackets or not. A for loop will generally print the first statement that comes after it if there are no curly braces, okay? So it will keep doing this. So what it's going to do is go through this list and say, take each value and say, okay, add 10 and update it, right? However, it won't be updating the original array, and that's the key we need to know. Enhanced for loops don't update the original because this is now a temporary variable which is standing for the first value, and it's just updating that temporary variable and printing it out. So we should see the value of 14, 12, 19, 17, 13, and then followed by 4, 2, 9, 7, 3. Okay, so I would say the answer should be D, non-updation of the for loop. All right. Okay, 11. I think we have a very similar concept here in this question. This is saying we have an array nums, which has been declared, which statement updates nums so that each element contains the square of its original value. So let's take a look at this while loop, the first one. So we have a while loop, k is less than the length, and starts at 0, and we say k equals nums k times nums k, but with our loop, we never update the value of k. K never gets updated here. So therefore, it will just be infinite. Keep going around and around. K will always be 0, never change. So I would not recommend 1. This one is a standard for loop, starts at 0, less than to the length. It then says nums k equals nums k times k, and k value is changing each time, so this would do the job. For this one, it's an enhanced for loop, and as I said in the last question, enhanced for loops do not update the value, right, of the list. Don't update the original list. So therefore, the n times n will only work temporarily. It won't actually change the original list. So therefore, the only one that really works is 2. I can say 2 only. All right. Question 12. Okay. So now this question is about shuffling, a shuffle method. And it returns all the elements from nums, but in a different order. And let n be the order of the number of elements in nums. The shuffle method should alternate the elements from 0. Let's look at the example. So we take nums, and then we put in 10, and then 50, and then 20, and then 60. So it's alternating the first part with the second part. And here, first part, second part, and it's alternating them into the list. All right. So it's saying it doesn't work as intended, and we would have to look through this code to try and figure out where the problem is. My suggestion here is I can already tell this is going to take some time to figure out. If I can check the boundaries, but we're using n divided by 2, which is breaking up the list into 2 parts, right? And we're half the index is here, half the index is here. In this case, n is 7, n is 8, right? 0 to 7, so it's 8. 8 divided by 2 is 4, and the first half is less than n divided by 2, right? So it's processing the first half of the list. It's saying each value equals the num. This is going to take some time. To check off all of these, I can't see any obvious errors here. And as I've only given myself 2 minutes per question, I'm going to skip this question altogether. Maybe this is a non-standard way to deal with it, but I don't want to waste time. I'm just going to go ahead, skip it, and then come back later and see if I can solve it. Okay, so let's go ahead. Question 13. Sort method sorts the integers into elements into ascending order. Okay. Which of the following changes to the sort method would correctly store the integers into elements into descending order? Okay. So here we have the sort, and it depends on whether you can recognize what kind of sort's happening here. This is running through the list, right, from the start to the end. It's setting the index equals j, and then it's going and finding, let's see, go through, okay, so from j plus 1, so go to the next element, all the way to the end of the list. If the element there is less than the element at index, so we're saying if we can find one that's less than this index value, then we're going to index is equal to k. At the end, we're going to swap out these two ones. So when we do that, this is a selection sort. If you can remember the sorting algorithms, where we're looking for the smallest value in the list, in the rest of the list, and then we're going to find that smallest value and then swap it into the next that position, right? So the outer loop is going to be going through the list one by one. The inner loop is going to be finding the next smallest value and then swapping it back into the end of the sorted list, right? The one we've been moving through. So this is selection sort. So to do it in descending order, we would need to change certain elements of this. Instead of looking for the smallest one, maybe we should be looking for the largest one. Okay, so line 9, I would say we should be probably swapping that and then keeping track of which one's the largest one. So here, line 9 would be changed. That's true. So 1 definitely is the kind of thing that we could do to swap it. There may be another one, but let's check if we can eliminate any answers. So anything that doesn't contain 1, like B, all right, only B, all right. So let's see we'll see about the other ones. All right, so replace lines 15 to 17 with, and this. Okay, so now this is the swapping part. Temp equals elements J equals element index equals temp. That's a general swap code. This temp equals elements index equals elements J equals temp. What does this do? Does this do the right thing? Well, this is swapping the two things. So all it's doing is in different order, right? So it's basically swapping elements J and elements index, but just in a different order. That doesn't really help us. I mean, it's not going to affect the results by swapping these two values in a different order. Like, we're still swapping the values. So anything that includes 2 is out. So this one's out, this one's out. So now we have only this one or this one. So A or D. So now we have a 50-50. Let's look at 3 quickly. Okay, so we say int J equals elements length minus 1. So this is starting at the end of the list and going back to the start. And line 7, we're going here and looking for up until this part, right? So instead of looking from the, like, starting with the outer loop is starting at the start, we go start at the end and we find the smallest value, right? But we still were looking for the smallest value, right? And we're still going to be putting it into, so we're basically processing the thing in a different order in the outer loop. Now, will that affect index J? So we're now putting the smallest at the end and then working backwards. So that actually might work. Find the smallest one, put it at the end. Find the next smallest one, put it at the next end, next end, next end. So I think our answer should be 1 and 3. 3 sounds pretty good. I really don't have time to go and keep verifying, but I think that we are on the right track with 1 and 3. So that one took a little longer, but hopefully we can make up the time. Okay, so following method mystery. We take a list of integers called nums. We're going to go through nums.size, right? Standard for loop. If we get the value and we take the int value and it equals to 0, then we remove it. So this is removing when we have a 0 from the list. Now let's remember, okay, if we're removing from a list while we're processing that list, what's going to happen? Well, the index is not going to match what we're actually doing. So we may be skipping values here. So once we remove this one, now the whole list moves back, right? So now instead of this being index 0, this is going to be index 0. But then we've already moved on. So when 2 zeros are in a row, it's going to skip the next 0 and process the next one, right? So I think what we're going to end up with here is this one's going to process okay, and I think this one's going to process okay. So we will remove this one, we will remove this one, so we'll end up with still we'll have this 0 because it will get skipped at the start. So we'll have 0, 4, 2, 5, 3, and I think it should get D. Now I haven't checked if there's any bounds errors, probably should have done that. But my first suspicion was that's what it's testing here, knowing that it's going to update the array as it's processing it. Okay, 15. So we have a list of animals, which are strings. And then we add cat. So this question, as I can see, is testing do you know how the add, set, and remove commands work when it comes to array lists. So we add dog, cat, snake. We have a list of dog, cat, snake. Then we set 2 to be lizard. Now, the list started 0, so 0, 1, 2. The thing that was snake is now become a lizard. So it's dog, cat, lizard. Now we add at position 1 a fish. So instead of dog, cat, lizard, it's now dog, fish, cat, lizard. Now we remove 3. So 0, 1, 2, 3. Lizard is gone. So it should be dog, fish, cat at the end. Does that give us A? Okay. So remember, this is the index that is inserting, and this is the value that we're inserting it at, right? So set is changing, add is adding, so it moves all the other ones across. 16. All right, here we have a 2D array, 3 by 4, 3 rows, 4 columns. So here we start at 0, it's standard. This is using the first row to get the length. So the length of the first row, right? The length of the first row, well, it's going to be 4, right? As you see, each row has 4 elements, so they're all the same. So yeah, so basically this is saying the length of the first row will be 4, so it's going to process all of the columns. If row is less than column, so the grid will equal 1. If row is equal to column, it'll equal 2, and else 3. So we're looking for which of the contents, and it's written in here. So let's look at the conditions. If row is less than column, we get a 1. So if row is less than column, we get a 1. So here row is 0, this is row 0, right? And column 0. So row is not less than column, it's equal to. So row is less than column, yes, yes. Right? Here row is 1, so then we should only get a 1 there. Okay, so this makes sense. This one formation there makes sense. So this one's out, and this one's out. And I would say, to some extent, we can also cancel this one out, because here we have 4 rows and 3 columns, when we know that we have 3 rows and 4 columns. So ignore these 2 anyway. What we're looking for here now is 3 rows, 4 columns. So it's D or E. If you can recognize that, you've made it simpler. So let's see. Now on row number 3, so 0, 1, 2, 2, we're only going to get a 1 here. We should get a 1 here, because the row is 2, the column is 3, and then we get a 1. And here, we don't get a 1, we get a 3. So our answer is D. I think we've narrowed it down enough that we can now say, don't need to look anymore. Okay, question 17. Okay, we have a util class which contains 2 methods. The sum1D method returns the sum of all elements of the one-dimensional array A. Okay, so we take the thing here and we return the sum as an integer. It doesn't show us what it's doing. It doesn't show us how it does it. We can just assume that's what we get. The incomplete sum2D method is intended to return the sum of all the elements of the two-dimensional array M. So here we have a 2D version with missing some code. And we're trying to fill in what that is. So all you really need here in this case is to do a traversal of the 2D array. So we're looking for a correct traversal, okay? Now, note that this method here, the sum1D, we can use that, okay? We can give it an array and it will give us the int of the sum. So I suggest that for each row in that 2D array, we give, because the rows are basically they are basically arrays themselves. So we'll give each of the rows to sum 1D, and then we'll give the answer. Right? So here we go to k equals m dot length. Now, m is the matrix, so that stands for matrix. We're going through the whole rows, okay, so that's right, from 0 to the number of rows, and then sum will plus equal the result of sum 1D for that row. So we're actually putting that particular row in there, sum 1D. So it seems to me that that's a pretty good way to do it. Here again, we're using an int array as the row, and we're putting that into sum 1D and adding it. So that works as well. This is just an enhanced for loop way to do the same thing. And now this is slightly different because this is now trying to do an enhanced for loop, and then it's trying to take each value in that row and say, okay, say the value is an integer. So it's actually doing the job, which actually I would say sum 1D does. So this would do the job of adding up all of the rows too, because we're just processing each individual item, right? So while it's unnecessary, we can still do it as all of them. So the answer would be E. You can do it all of those different ways. Okay, 18. Consider the following classes: public class base, okay, base, and we're just printing base plus a space. Okay, that's the constructor. And now we have an extension, so derived extends base, and derived will print derived plus space. And then we say, okay, let's make a new derived object. What will be printed? So the key to this is recognizing that if you don't see super in here, you should consider that it's there. It's invisible. Java will add it. So super is going to get run. Super will run the default constructor or the blank constructor for the superclass. Therefore, base will print out first, and then derived will print out first. So we should end up with base derived. Okay, so the key here is to remember that super prints out, or will go in there first, if it's an extended class from the superclass. All right, question 19, we have add fun method, and we take an input here, and if the input is less than or equal to 0, we're going to return 0. If it's 1, we're going to return 2, and then we're going to return, if it's none of these, we're going to return the same method, right, with n-1 and n-2 added together. So it's the sum of the results of these functions again, right? So this is a recursive call, and these are our two base cases. So it's going to terminate when we get to the base cases, but we really do have to work out how many cases we're going to have, right? And so the trick with this is recursive calls basically need to be evaluated to their base case. So let's take this, and let me go to our notepad. This is where you might need a notepad for your question, okay? So what's it called? Add fun. Okay, so we're going to say add fun, I'm just going to say add fun 6. Okay, this basically is going to come out to add fun 5 plus add fun 4. Right? So now let's take that add fun 5. The add fun 5 is basically add fun 4 plus add fun 3. According to the rules, the add fun 4 is basically equal to add fun 3 plus add fun2. We still haven't reached the base case yet. Add fun3 is equal to add fun2 plus add fun1. We're almost at the base case. Add fun2 is equal to add fun1 plus add fun0, and finally we're hitting the base cases. Okay, so we can now go look at the question and then see that here the base cases are 0, which returns 0, and 1, which returns 2. So 0 is returning 0, so we can sort of ignore that. That's a 0. And the 1 is returning 2. Okay. So now I can replace add fun2 with 2, because that's what it equates to. And now add fun2 can be replaced with a 2. Add fun1 we know is a 2 also. So now add fun3 we can say equals a 4. So I replace add fun3 with the 4. Add fun2 that we know is a 2. So now we know that add fun4 is a 6. So I replace add fun4 with a 6 plus add fun3, which we know is a 4. And so we know that add fun5 is a 10. So we replace that with a 10. And we know add fun4 is a 6. So therefore, add fun6 gives us 16. And that would give us C. Recursive calls, lots of fun. All right, that takes us to question 20, and then we can go back and do the one we skipped. All right, here we have another recursive question. We are looking at an array and which contains no duplicates. They're in ascending order, and we have two parameters, a low and a high value, and num is an integer. So we have a low and a high and an integer. That this usually is a sign that we're looking for some number here. That's our sort of target number we're looking for, and we've got a low and a high point, which means we're kind of looking at this array with a low and a high as the index. So these kind of questions are talking about these index values, and a midpoint here is established between the low and the high. So we low and high divide by 2. If low is greater than high, return the low. So meaning that if we get to a point at which the low crosses over the high, it means we're kind of done. And we don't need to go any further because we can end our search. Okay. If we are, let's see, if array mid is less than num, so if the value in the middle is less than num, then we're going to return mystery, and we're going to apply that to mid plus 1, to the next value along from mid, right? So looking deeper at this one, it seems that if our value in the middle is less than the number that we're looking for, or that we're comparing to, then we want to keep searching in the higher part of the array. Now we know that this is in order, so the lower values at the start, higher values at the end. So we keep searching, right? Meaning that we're looking for numbers which, or at least we're tracking to see, we want to find the value of mid. We want to find the value of num, but if we haven't found that, we're going to keep searching the higher part. If we do find in the higher part, if array mid is greater than num, we're going to search in the lower part. And then finally, if we actually find the value of num, then we're going to return that midpoint, Okay, so if it's at this index, and we find our number, we're returning the midpoint. I want you to consider this case here, right? This base case. Base cases sort of give you the clue for how we're terminating. If, let's say we have an array of let's say 5 elements, and so the length is 5, divide by 2 gives us 2. If we find it at the index of 2, we find the number, then we're returning 2. So that means that if we're saying, okay, I've got 0 and 1 are both lower than my number. So in a way, what you can say about that is that this algorithm is looking for numbers which are lower than that number. So as you see, if we're returning the mid, and that's a 2, there are 2 numbers that are lower than the number. And so therefore we can sort of get an idea that what this algorithm is doing is it's finding how many numbers are less than num. Not equal to. If we find the number at mid, right, at the midpoint, we're not including that in the return statement here. So I would say that we're finding the number of elements in an array that are less than num. Okay, so that seems to indicate that that would be answer A. Yes. Okay, now it's time to go back and try and sort out the mess that we left before. Where was my question where I had an issue that I skipped? Here, shuffle method. Okay, so if we do have time, and if you know, this is where like we try and get the easy ones. If something gets messed up, then we come back and do it again. That's the best way to proceed with your exam. So shuffle method, we're trying to find where the problem was in the shuffle method. And I recall that we sort of established that there were no bounds errors. If you can test this out on different lengths, like odd lengths and even lengths, it still worked out. Like, so if we divide by 2 on a 7, we get a 3. If we divide by 2 on a 6, we get a 3. 3 times 2 gives us 6 plus 1 is 7. So if our length was, actually, let's see, if our length was 6, so n would be 6. 6 divided by 2 would give us 3. J is less than 3, so the J maximum value would be 2. 2 times 2 would be 4 plus 1 would be a 5. A length of 6, the maximum index would be 5, right? So we've tested the boundaries. The boundaries seem to be okay, right? This evaluates the same thing. If J, so if let's see. So if the length is, again, length is 6, 6 divided by 2 is 3, and if J is maximum 2, that takes us to 5 here. So the 5 would equal to 5, right? The result 5 would equal nums 5. So that seems to be not the issue, right? So A is out. The first element may not have the correct value. Well, first element, J times 2, 0, it should equal nums 0, right? The result should equal nums 0 because we know that the first one should be the same as the last one. So it seems like the first one is fine, okay? And the first one, and this is the next one, like plus 1, should equal the half plus whatever J is at. So this one seems to be okay too. I think that we've got, see, the half, we got the half plus 1. It fits there. So I think the first element seems to be fine. First element seems the correct value. That's not right, that's not right. So now we've got C, D, and E. If you're really running out of time, there you go. You got 33% chance of getting it right. But let's keep pushing on. The last element of the return array, result length minus 1, may not have the correct value. So the last element may not have the correct value. What should it be? The last one should be, well, I guess it should be, if we look at it, it should be the last element of nums. Goes there. Last element of nums goes there. Can we find that that's the error? When nums equals 6 in this array. So the length of 7, right? And we have the j equals 0. J is now equal to 6 here. Sorry, no wait. J less than n divided by 2. So 7 divided by 2 is 3. So 3. So j is 2. And j plus plus. This is the even one. Will this give us the odd one? So 3 times 2 gives us 2 times 2 gives us 4, plus 1 gives us 5, and then nums. So how do we ever update the result of 6 here? If 7 is here, right, 7 divided by 2 is 3, and j is going to be maximum 2, and then this is meant to be updating the last value, the end, so the edge case. How does 2 multiplied by 2 give us 4, and 5? How do we ever access this value to get to 6, the index of 6? We don't. We never get to update result j times 2 plus 1. So we are missing out on the last value to update. So result, the last value may not get the correct value. So I think we found the answer there to be C. I don't think I need to look through the rest. I think I found the answer. For some reason, the last part won't get updated in this. And that brings us to the end. Okay, so I've shown you some questions here which are pretty tricky. I would say that they're not super easy. That's why it becomes really essential that you do your best to take your time and find out the sort of like the easier questions first, rather than moving so fast to like invest all your time in one question. Okay, so that was 20 questions for the 2020 exam. I don't know why I said 2020, because it's actually 2022 as I'm recording this, so that's my bad. I should probably update that. 20 questions for the 2022 exam. I will redo that, and hopefully that's what you're seeing now. So best of luck. Hope it all goes well, and catch you on the flip side.